Hello, everybody, and welcome to Friday. Before we jump into our lesson today, I just want to mention that the grading for quarter two, semester one ends today. However, there will still be work next week. So please do not start your Christmas vacation early because I will be having you do some more lessons next week as well, still relating to systems of equations. So systems of equations is what we're learning about now, which is part of our overall theme of functions about modeling and predicting change. So here's where we have left off from yesterday and have been studying this week is how can I model two or more events that share a common solution. And so we realize this is what we call a systems or a system of equations. So there's our definition again about what a systems of equation is. And then today we're going to be dealing with a special type of one solution equation. So we know that when we have a one solution system of equations, that it makes intersecting lines. And those lines intersect at a common point, and that common point is the solution to the system of equations that will make both equations true. All right, so this is the one solution equation which creates intersecting lines, as opposed to the no solution equation or systems that we dealt with yesterday, which created parallel lines. So here are two lines graphed, and these lines are perpendicular lines. Now, you probably learned this back in fourth or fifth grade or earlier, that perpendicular lines are intersecting lines that create a 90-degree angle. But what we want to look at today is the question, what do you notice about the slopes? So we have here two lines that are perpendicular. One has the equation y equals 3/2 x plus 5. The other has the equation y equals a negative 2/3 x plus 2. So take a moment now, look at those two slopes, and what do you notice before I tell you the answer? Okay, hopefully what you noticed is the slopes are opposites. So one is positive and the other is negative. So I have a slope of a positive 3/2 and a slope of a negative 2/3. And this is what we would call negative reciprocals. Because the other thing hopefully you noticed is that they are reciprocals. You may have used the term before multiplicative inverse, but a reciprocal is basically when we flip the fraction. Or a fun way to remember it is flipped over fraction friends. So when you have two lines that are perpendicular, their slopes are opposite reciprocals or negative reciprocals. Okay, just so you know, for every math teacher there is in the world, there is a different way to teach this. Some will use the terminology opposite reciprocals like I do, which I think is easier and more friendly of a way to remember things. Some might use the term negative reciprocals. Others might use the negative multiplicative inverse. So just be aware of that. Know your audience, know your teacher, know your crowd. So here we go. Let's look at our examples for today. So our first example is to write an equation of the line passing through 2, 2 and perpendicular to the line whose equation is y equals 2x plus 2, and express the equation in point slope form and slope intercept form and insert a graph. So the way we're going to do this, everybody, is the same way that we found the slope of a parallel line yesterday. Okay, so what we're going to start with is we'll write the equation of our current line, which is y equals 2x plus 2. Okay, and we're looking for a line that passes through the point 2, 2. Okay, so in order for me to use point slope form to find the equation of the line, I need to know a point, which I know my point, 2, 2, and I need to know my slope of the line. So if we're looking for a line that is perpendicular, what we already said is that it's going to be the opposite and the reciprocal. So in the equation y equals 2x plus 2, my slope is a positive slope. So the opposite of a positive slope is going to be a negative slope. And the reciprocal of 2. So remember, anytime you see a whole number or an integer by itself, it's always, when written in fraction form, we put a 1 in the denominator, which is 2 over 1. So if I'm going to flip this and write the reciprocal of it, or the multiplicative inverse, what I'm basically going to do is the numerator, which is on top, becomes my denominator, and my denominator becomes the numerator. So the reciprocal, or the opposite reciprocal of 2x would be 1/2 x. So in my new line, my slope is going to be a negative 1/2 x. So I'm going to have here y minus 2 equals a negative 1/2 times x minus 2. And then at this point, I just distribute like I did yesterday. So a negative 1/2 times a negative 2 gives me a positive 1. So the equation of a line that is going to be perpendicular to the line y equals 2x plus 2 that passes through the point 2, 2 is going to be y equals a negative 1/2 x plus 3. Okay? Y equals a negative 1/2 x plus 3. So if we come over here to Desmos, we can graph both of our lines. So we'll graph y equals 2x plus 2. And then we will graph y equals negative 1/2 x plus 3. All right. So notice there the lines are perpendicular because when they cross, they make a 90-degree angle. And y equals a negative 1/2 x plus 3 passes through the point 2, 2, which is right here. Okay, so here's the point 2, 2. All right, so we'll do the same thing that we did yesterday is we will screenshot and go ahead and put this on the slide. And this is our example. So here's example number 1. Okay, so that's what it looks like. So as you see, the slope is opposite, it's negative, and it's the reciprocal 1/2. All right, so let's go to the next one. All right, so this one says to write an equation of the line passing through negative 6, 1 and perpendicular to a line whose equation is y equals 3x minus 2. Okay, so we'll come over here, we'll do the same thing as before. Is the line that we have is going to be y equals 3x minus 2. And it's going, the next line is going to pass through the point of negative 6, 1. And my slope. So if I'm going to use point slope form again, I need to know what the slope is. So my slope is going to be the opposite and the reciprocal. So if I have 3x, it's a positive 3x. So this time the slope's going to be negative. And since it's the whole number 3, that is actually 3 over 1 is a fraction. So my numerator becomes the denominator, and the denominator becomes the numerator. So there is the slope. So y minus y1 equals negative 1/3 times x minus negative 6. So if we clean that up, 2 negatives make a positive. Then I'll distribute. All right, so we have 6 times a negative 1/3. So if I just multiply across, that gives me a negative 6 over 3, which equals 6 divided by 3 is going to be a negative 2. All right, so here we go. The equation of the line that is perpendicular to y equals 3x minus 2 and passes through the point negative 6, 1 is y equals a negative 1/3 x plus 1. All right, so all right, so there's our two lines. They're perpendicular because they make a 90-degree angle, and the point we were looking for was negative 6, 1. And so right over here is your negative 6, 1. All right, so let's go ahead and screenshot that. All right, there we go. Oops, cut off my equations. But all right, so there's what our lines look like. Okay? All right, so the next two we're going to do are lines that are in standard form. Okay? And next week we're going to be using standard form a lot more. So this will give you a good opportunity to work a little bit with standard form as we go through these. So we have here the equation of a line passing through the point 4, 0. And the equation of the line is 4x plus y equals 3. All right, so we'll come over here. And so we have an equation in standard form. And what we always need to remember is that the reason we write equations in slope-intercept form is so we can graph them on the coordinate plane. Okay, so I'm going to subtract the 4x from both sides so I can have this in slope-intercept form. So y equals a negative 4x plus 3. All right, so that's the equation of the line. So we're looking for a line that passes through 4, 0. So I need to find what my slope is going to be. So the slope is the opposite and the reciprocal. So I have a negative 4 over 1. So already I know the opposite is going to be a positive slope, and my numerator becomes the denominator, and my denominator becomes the numerator. So my slope of the next line is going to be 1/4. So y minus y1 equals m minus x1. So y minus y1 would be y minus 0 is going to be 1/4 times x minus 4. All right, and we'll just distribute. And then y minus 0 is 0, so we're just going to have y equals 1/4 x minus 1. Okay, so the equation of the line passing through the point 4, 0, that is perpendicular to the line y equals a negative 4x plus 3 will be y equals 1/4 x minus 1. All right, so let's go ahead and graph both of these lines and see what it looks like. All right, so there they are. They're perpendicular. And we see right over here the point 4, 0. All right, so there's the equation of the line that passes through 4, 0. All right, so there we go. Okay, we have one more to do together, and then there'll just be 5 problems for you to do on your own. And just like we did yesterday, we did 5 yesterday, we'll do 5 today. Because I already know you're pretty proficient at using Desmos, it's more of just moving these equations around and working with them. All right, so here we go. Write an equation of a line passing through 6, 5 and perpendicular to the line whose equation is 3x plus 4y equals 12. Okay. Alrighty, so let's go ahead and change this into slope-intercept form. So we subtract 3x from both sides. All right, now that I've done this, I need to divide everything by 4. So the y is isolated by itself. All right, so that there is the equation y equals negative 3/4 x plus 3. So we are trying to find a line that is parallel to this line that passes through the point 6, 5. Okay, so we know that my slope is going to be the opposite and the reciprocal. So the opposite of a negative 3/4, of course, is going to be a positive slope. So if my numerator becomes my denominator moves into my numerator, I'm going to have 4/3. The opposite, it's positive, and the reciprocal of 3/4 is 4/3. All right, so let's go ahead and use our point slope formula. So y minus 5 equals 4/3 times x minus 6. So when I distribute 4/3 to everything, all right, so 4/3 times 6 over 1. So if I multiply across, 4 times 6 is 24, divided by 3 equals 8. Add 5 to both sides. And I have y equals 4/3 x minus 3. So the equation of the line that is perpendicular to y equals negative 3/4 x plus 3 that passes through the point 6, 5 is going to be y equals 4/3 x minus 3. Okay, so let's go graph both of these on Desmos. Oops, that one should be positive. There we go. Okay, so I have the perpendicular lines, and let's look for the point 6, 5. So over 6, up 5, there we go. So that line does pass through 6, 5. All right, so here you go. Here's the graph. Okay, so what you're going to do for the rest of these is the first 2 are both in slope-intercept form. Then 3, 4, and 5 are all in standard form. And then finally, insert a photo of your calculations. Okay, so have a great day, everybody. Thank you for listening. Thank you for turning in your work and doing a fantastic job of it each and every day. And have a great weekend, and there will be some more learning on Monday. Goodbye.